Hi guys, Mr. Wallace here. No big preamble today, I'm just going to get straight into it because this could turn into a long video if I keep it up. There's two questions on the screen for you, okay? I want you to pause and make sure you have a read at them, make sure you can answer them. Our topic is the next part of this bigger ratio topic today, which is sharing in a ratio. Okay, getting into it. First thing I want you to think about is, how could I share £10 between two people, okay? Little thought exercise to help you get started. The first and most obvious way most of us might think to get started with this is to share between the two people equally, okay? So that would mean I would take the £10, split it into two equal parts, so divide it by 2. Just taking the two numbers. That would mean each person would get £5. That's our most obvious way. There are other options though. Maybe there's £10 for doing a job for someone, okay? And one person did a bit more of the work or agreed to get a bit more of the money in advance. In that case, what you would do is you would split it up unequally. You might say person 1 did a wee bit more, so they're going to get £6 of the pounds. Person 2, they still worked hard, but they'd agreed to do less of it to begin with, so they only get £4 of the pounds. Now, hopefully you can see what you've actually done there is shared that £10 in a ratio to an extent, okay? Because what you've done is said for the £6 that person 1 gets, person 2 is getting £4. And going even further with that, you might hopefully notice that that actually simplifies, just like a ratio does, as we've seen in previous videos and examples. So we can divide both sides of this by 2, and we end up with the ratio 3 to 2. So that £10 in our second example here has been shared in the ratio of 3 to 2. Okay, that's really all that sharing in a ratio is. It's splitting something up unequally. One of the two people, one of the two sets gets more than the other, and we need to figure out how much more. And we have a process for this, okay? There's 4 steps that you need to be able to follow, and we will go through them here with part A of this first example. We'll consolidate that with part B, okay? Main focus here is what are my 4 steps in sharing a ratio, okay? Example 1 reads, share £12,000 between Tom and Karen in a ratio of either A 1 to 2 or B 5 to 7. We're going to start off by doing A and talking about the steps. Step 1 is to figure out how many parts am I going to have to split this £12,000 up into. So total number of parts, okay? Now, Tom gets 1 part and Karen gets 2. So how many parts are there in total? You just add the ratio up, okay? You're going to need to do 1 plus 2 with 3 parts. So there's 3 parts to deal with. We're going to have to split that £12,000 up into 3 parts, and that's what we do for step 2. Step 2 is find out how much each part's worth. And to do that, all we do is take the £12,000 and divide it by the total number of parts. So we're going to have 12,000 divided by 3. It's a quick and easy way to do this. How many times does 3 go into 12? It goes in 4 times, and then we just keep the 3 zeros, okay? So each part is going to be £4,000. If you needed to, it's perfectly okay. The work I'm setting in my class will be optional for a calculator, so it's perfectly okay to go in and use a calculator to double check this, okay? 12,000 divided by 3 for 4,000. Now obviously you shouldn't need it for this one, but that could come in handy for you in some questions later on when you're practicing. So now we know that each part of this ratio is £4,000. Our last 2 steps are to say, in step 3, how much does Tom get? And in step 4, how much does Karen get? Okay, so step 3 is, what's Tom's share of this amount? Well, Tom gets one part, and each part's £4,000. So what we're going to do is the £4,000, the value of the part, multiplied by how many parts Tom gets. That means Tom's share is going to be £4,000 because it's just 4,000 times 1. We do the exact same thing for Karen. We just look at how many shares she's supposed to get. Okay, so for step 4, what are Karen's share? Karen's share is the £4,000 for each part, but she has 2 of them. So £4,000 times 2, 4 times 2 is 8, and then we keep our 3 zeros for £8,000. And that's all that's involved in one of these questions. If you do need to check it, or if you're not confident you got to the right answer on the first try, what you can do is take Tom's shares and Karen's share, okay, and add them together. And if they add up to the same as what you started with, you've got the right thing. So 4 plus 8,000 is 12,000. So you know you're right. Okay, that's all there is to the question. We'll highlight that just by going through the exact same question, the exact same number, but splitting it up in a different ratio. Okay, we'll change colour of pen to make sure you can keep track of what's going on. So this time we're saying, can we share £12,000 between Tom and Karen, but in a ratio of 5 to 7? And our steps remain exactly the same. We're going to start off by finding out how many total parts are there in this ratio, and that's the 5 plus the 7, for a total of 12. Step 2, we figure out how much is each of those 12 parts worth. So each part is going to be worth £12,000 divided by 12. And this one should be even easier. 12 divided by 12 is just 1, so it's going to be £1,000 for each part. Okay, so each part is going to be worth £1,000. We go back to step 3 and 4 and do the exact same thing as we did in the first example. We find out what Tom's share was. And Tom got 5 of these £1,000 parts. So 1,000 times 5, we're taking how much the part's worth and multiplying by Tom's side of the ratio, meaning his share was £5,000. We do the exact same thing in step 4 to find Karen's share. Okay, and she has, this time, 7 of these £1,000 shares, parts. So Karen's share was £7,000. 1,000 times 7. Lastly, we can do exactly the same as we did before, double check. Does 5,000 and 7,000 add up to give us 12,000? Yes, it does, so we know we've done the right thing, and that's us done with the process. Okay? And that's all there is to working this out in the questions that you should see for it, okay? These 4 steps, make sure you go through them every time, and you shouldn't be able to go wrong. Just to reinforce this, we're going to look at a wee example that doesn't involve money, and it's maybe a little bit harder. And one of the only things they can add to this, for a bit of difficulty, is asking you to come up with that ratio, just like they did in ratio calculations that we looked at last week. Okay? So, example 2 reads, bronze metal is an alloy of copper and tin, which means it's a mixture of copper and tin mushed together. In a particular sample of bronze, there's 84 grams of copper for every 12 grams of tin. And that's giving you a clue to the ratio we might be thinking about there and there. Okay? It's saying write down the ratio of copper to tin in its simplest form. So we're going to have to simplify. That's the big clue in that part of the question. What is the ratio of copper to tin? Well, we just take the amount of copper and equate it to the amount of tin. So it's going to be 84 to 12. Now, we need to simplify this, and there's a bunch of ways you could go about this. You might divide by 2 first, because that seems dead easy. But if you can, pause the video for a wee second and see if you can figure out what the highest common factor is. Okay? This is a really obvious way to figure it out in some of these questions when it looks a bit tricky like this. And that is basically, if you've come back after a pause, to just try the smaller number in the ratio and see if it divides into the bigger one. So will 12 go into 84? Yes, it will. So we're going to divide by 12. Okay? We divide by 12, you get 7 on this side to 1. 12 divided by 12 is 1. Okay? Remember, you can check any of this with the calculator as you go. Hopefully most of us will have at least a bit of familiarity with our 12 times table. Now part B is asking how much of each element is there if the total weight of the sample, so the whole bronze sample, weighs 2.4 kilograms. And this is the part that's asking us to use our 4 steps and share in a ratio. Okay, so it's saying how much of that 2.4 kilograms is copper and how much of it is tin. To do that, we just start off with the same step 1 as before. We're going to find out how many total parts do we need to split this 2.4 kilograms up into. And that's taken from the ratio. It's 7 plus 1 to give us 8 total parts. Okay, so we need to split this up into 8 parts. Step 2. How much does each part weigh? Remember, in this case, we're looking at weight, so how much does it weigh? Each part is going to weigh the 2.4 kilograms divided by 8. And if you're struggling with this, there's a couple of ways you can do it. Okay, you could start off just by trying a wee division sum. It's straightforward if you give it the time. So we've got 2.4. 8 doesn't go into the 2, but we can carry the 2 over. How many times does 8 go into 24? 3 times. You need to bring that decimal point up though. Okay, so that means that each part is going to be 0.3 kilograms in weight. If you needed to, there's absolutely no harm in trying that with your calculator. 2.4 divided by the 8 will give you 0.3. Okay? All that's left to do now is that step 3 and that step 4, which is step 3, find out how much copper, and step 4, find out how much tin is in this bronze. So for step 3, we're saying the copper makes up, okay, and it's each part is 0.3 kilograms. How many parts are copper? 7 of the 8. So we're multiplying by 7. Again, this one's relatively straightforward if you know what you're doing. 7 times 3 is 21. We need to bring that decimal point back in from the right. We'll have 2.1 kilograms. If you're not comfortable, again, just double check that with your calculator. 0.3 multiplied by 7 or 2.1 kilograms. That's our weight of copper. To get the final answer, we need the other part of the ratio, which is how much tin was there. For that, we do the 0.3 for each part. And this time we're multiplying it by how many parts were there of tin? 1. 1 part tin, okay? 0.3 times 1 is just 0.3 kilograms. And that's our two final answers, 2.1 and 0.3. For a last time, if you just add them both together, that will tell you if you're correct, because the number should match this one here. Okay? 2.1 plus 0.3, you're just adding the 3 and the 1 there to get 2.4. So you know you're correct. Okay? That's all that's involved in sharing in a ratio, guys. It's just those 4 steps and maybe a little bit of problem solving to do with your ratios to begin with. Most of your questions, if you're seeing them from my class, should look relatively similar to these ones. If you have any confusion at any point, remember you can come back and watch this video again for a bit of advice. Contact your teacher or someone else that might be able to help you. But to wrap up, make sure that you look back at these 2 questions and know how to answer them, because these will give you the steps you need to do these problems, okay? Otherwise, guys, I hope you have a fantastic week and a really good weekend when it comes to you, and take care.